can we limit the probability of the existence of life outside of our solar system? And the fact is that Mars had liquid water on it, we believe. It had, potential to support, a microbe, airdropped onto Mars 2 billion years ago, could have survived potentially. But can we not say something about the overall global odds? I've never seen this. I've seen the Drake equation. I've seen,
No.
yeah,
I mean, what we know is that Mars has a lower surface gravity, so it couldn't retain its atmosphere. And a couple of billion years ago, it lost its atmosphere. Now, before that, it had liquid water on the surface. And what forms of life it had, we don't know. And that's part of the mission of the NASA rovers that are being sent. Frankly, I mean, personally, I believe that we have a better chance of finding traces of any early life on Mars in the caves, in the so-called lava tubes, which are these caves that are underground, protected from cosmic rays, and are not really affected by the extreme temperature variations on the surface after the atmosphere was lost. And I'm particularly interested in going into these caves, the lava tubes, and searching for any wall paintings, because maybe intelligent life developed on Mars twice as fast as
yeah,
it did on Earth. A factor of 2 is not a big factor. And of course, today they would not be able to survive. There is no atmosphere. All the liquid water evaporated. But if they existed, we might find some wall paintings. And moreover, we might find some skeletons in these lava tubes. So that's my personal interest, going with a drone into these lava tubes and examining them.
well, yeah.
But
Mm-hmm.
we cannot say at the moment how to calibrate. We cannot say whether there was life on Mars and how advanced it was until we find any traces of it. Just one thing to keep in mind: even suppose there were cities on the surface of Mars, you might say, "Oh, we don't see any high rise." Well, the point is that any square kilometer of Mars was bombarded by 20 Hiroshima atomic bomb explosions triggered by asteroid impacts. I calculated that in a couple of billion years, you basically get 20 atomic explosions per square kilometer, and any high rise would be demolished as a result of that. So, not to speak about
Yeah.
any living creatures. And obviously, without an atmosphere or liquid water, they would have a hard time surviving.
I first want to start off with some images. So I have an image here. I always like to joke about. It's a very interesting image. I'll just pop on the screen. You won't be able to see it, but it's Meteor Crater, Arizona. Have you ever been there, Avi?
No, I've seen images of it.
So if you remember the images, there's this huge, 1, plus kilometer crater, and then I always joke, it's so cool that it struck right next to the gift shop. And of course, they built the gift shop later. But my question for you is, when you look at these objects, when you find this object, you should go through the calculations that led you to conclude, or in the government to agree with this calculation, that this was interstellar, but then that you found in Papua New Guinea around the most likely trajectory impact zone, you actually found these spheral. Is it a just so story? Is it just like this gift shop appearing next to the meteor crater in Arizona? And if so, if not,
Right.
why?
So let me explain. First of all, from the crater, you only infer the kinetic energy, the energy carried by the object that impacted the Earth. And that doesn't tell you separately the mass of the object and the speed that it came at. It tells you the product of the mass times the speed squared. And that's all that you can learn from the size and the shape of the crater. So when examining impacts on Earth, we can't really tell where these impactors came from. We can't say whether it's solar system origin or interstellar origin outside the solar system. What was special about the meteor from 2014 is that the US government satellites and other sensors detected it when it exploded in the atmosphere and could measure its speed. And they measured the speed of 45 kilometers per second in some direction, and we went back in time and realized that it was not bound to the sun. It was moving faster than the escape speed from the sun, and moreover, it was moving very fast, even outside the solar system. So we put that in a paper, and the paper was not published because the referees argued, well, we don't know the uncertainties in the government data, and obviously the government doesn't want adversaries to be aware of the sensors that it's using, so it didn't reveal the uncertainties. And it took them 3 years to end up confirming, as you said, at the 99.999% confidence that indeed the aero budget is extremely small, which is what I expected, because they are responsible. Their day job is national security. They have to figure out if a ballistic missile is heading towards Washington, D.C. So they have very precise data. They put their reputation on the line. But I should say, on the day that we came back, there was a paper published in the Astrophysical Journal by two astronomers who argued that they are trying to fit the government data with their model for stony and iron meteorites, and they cannot do that. And therefore, their conclusion was the data must be wrong. The speed that was measured must be a factor of a few smaller. Now, the way I was brought up is if your model doesn't fit the data, then you revise the model. But instead, what they say, quite arrogantly, I should say, is the data must be wrong because our models for solar system rocks do not fit it. Well, I said that long ago. I said the material strength of this object was different than solar system rocks. That's why the models didn't fit it. And just think about the rotation curve of the Milky Way galaxy. You might argue, oh, the rotation curve of the Milky Way galaxy cannot be fit with assuming ordinary matter that we find in the solar system, and therefore the data must be wrong. Well, no, cosmologists all over the world for, by now it's 90 years, are worried about what this matter might be. They call it dark matter. That's a main area of research with billions of dollars dedicated to finding what the dark matter is. But if we were to use the same logic, we would say we don't see this matter in the solar system as of now, and therefore the data must be wrong. And that kind of logic perhaps is adequate for traditional fields that focused on space rocks, but intellectually that's not suitable for exploring the universe beyond the solar system, because we know that 83% of the matter in the universe is of a substance that we don't find in the solar system. And moreover, we launched probes out of the solar system, so why not allow for the possibility that this object may be a Voyager from an exoplanet?